Lately, the world of astrophysics has been caught in a quiet panic. They call it the Hubble tension. Simply put, the more precisely we measure the expansion of our universe, the more the underlying math falls apart. Depending on where we look, we get two entirely different speeds. But what if the math isn't broken? What if we've just been ignoring the weather of space itself? What if the vacuum isn't an empty stage, but a physical medium with its own currents and tides? Standard models treat space like a void, a perfect nothing. But in our framework, space is a saturated fluid. Imagine it like a massive invisible ocean. Take the Boötes Void. It's a spherical region of nothingness, nearly 330 million light-years across. It should contain thousands of galaxies. It holds barely 60. Instead of an empty hole, imagine this as a massive low-pressure pocket in our cosmic ocean. Because the fabric here is stretched thin and calm, there is no inhale to pull matter together. It's a low-energy zone where the medium is at rest. Now contrast that with a massive, tightly packed cluster of galaxies. Here the density of this cosmic fluid is at its peak. The presence of all that matter creates a massive pressure gradient, a literal inhale that pulls everything toward the center. We observe this as gravitational lensing. Traditional astronomy says gravity is bending light, but if space is a fluid, the mechanics are simpler. Light is refracting through a denser medium. Just like a glass lens or a pool of water, these high-pressure zones slow down and warp the light passing through them. It's not magic, it's just optics. So why the Hubble crisis? Why do the measurements refuse to agree? When scientists look at the early universe, they are measuring a time when the entire medium was under extreme compression, hot, dense, and moving fast. They are measuring a high-pressure river at its source. But when they measure local expansion using stars closer to home, they are measuring it from within calm, low-pressure eddies, like the one our own galaxy sits in. Think of measuring wind speed. You wouldn't expect a gentle breeze in a sheltered valley to match the gale force winds on a mountain peak. The tension isn't a glitch, it's just a difference in pressure. The universe appears to expand at different rates because space itself is thicker in some places. The Hubble crisis only exists if you assume the universe is a uniform, empty vacuum. Once you account for the varying pressures and currents of space itself, the tension vanishes. We aren't seeing a failure of physics. We are looking at the very first map of the universe's hidden ocean currents. By understanding these high and low pressure zones, we stop being passive observers. This glitch isn't the end of our understanding. It's the blueprint for a completely new way to navigate the stars.